So hello everyone, today we're going to integrate this integral, which is just the integral of pi over 2 to 0 of the square root of sine x over the square root of x plus the square root of cos x dx. How do you solve this? Before I solve this, please make sure to leave a like and subscribe in this video, guys. Okay, so back on solving this. So we know that the integral, which is evaluated from a to b of a function, well, this equals to this. This equals to this, guys, because like we have the bounds here and then we add the bounds, but then we minus x2, so it's just the same, you know. This is also a definite integral identity. We can use a clever trick where we can let a as 0 right here and b as pi over 2, right? That's why when we have this, we substitute in pi over 2, right? Because pi over 2 minus x, like this. We substitute this into all these x's, and of course we have to substitute this into the x's because of that rule that we saw earlier. We can do that, so I'm gonna rewrite it now. So then our integral just becomes this, and then we also should know this. These are also very important trigonometric identities. We have sine x equals to cosine of pi over 2 minus x, and then this one the same. So then we can replace these values with this, right, guys? So then we have this integral where it's practically the same, except this is just cosine. But remember, guys, we didn't change anything. So these two integrals are exactly the same thing, guys. So then what do we do? Well, I'm going to let this as my variable. Let's say this I don't know, this expression is called I. Because this is also the same, I'm gonna also let this as I, because these two are the same, guys, because we didn't change anything, right? And then what I'm gonna do is really tricky here, but it's really creative. I'm going to add both of these integrals, leaving us with here, which is just 2i, right? And then this is just sine x plus cosine x, right? Or the square root of them. So we can rewrite both of these integrals. We can just add them up, which is just the integral of pi over 2 0. So then after I add them up, as you can see, it's leaving us with this. Look what we can do, guys. We can just cancel all of this, right? Oh yeah, don't forget the dx, sorry guys. So this just leaves us with 1, right? So this practically leaves us with 1. So this is gonna be the integral of 1 dx. I'm going to rewrite it over here. So this is just 1 dx, right? What is the integral of 1? Well, any constant that have that integral, you know, I'm gonna write the formula here. The integral of, I don't know, k dx, where k is a constant. This is just xk or kx, like this, and then plus the constant of integration. Don't forget that. Because we have only 1 here, what I can do is just replace this with x, right? But now we don't need the constant of integration because we have the bounds right here. So then we have x evaluated from pi over 2 to 0. Because this is 0 and anything minus 0 is the same thing, we can just replace this as pi over 2. And then what you look at that here, pi over 2 equals 2i. So then what does I equal to? Well, I is just the half of that, right? So I can just divide by 2. So I, as you can see, this cancels. 2 times 2 is 4, right? This is just 4. So then I equals to pi over 4. I also equals to the integral. So then our integral equals to pi over 4. That's it, which is roughly about 0.79 decimal forms. So this integral is pretty easy, guys, actually. So that's it for this video. I hope you can do the puzzle. Leave a like and subscribe. Bye.